September 27, 1941, Lakeland, Florida. The grinding of metal against concrete echoed across the humid swampland as engineer Donald Roebling watched his prototype crawl out of the murky water onto dry ground without missing a beat. What started as a rescue vehicle for hurricane victims in the Everglades was about to become the weapon that would shatter Japan's coral fortress strategy across the Pacific. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The machine before him wasn't pretty. Riveted aluminum plates formed a boat-like hull, while rubber-cleated tracks wrapped around both sides like a mechanical crocodile. But as it churned through sawgrass, over fallen logs, and back into deeper water, Roebling knew he had created something unprecedented. A vehicle that could swim like a boat and crawl like a tank, indifferent to the barriers that stopped everything else. The story begins not with military planners or battlefield necessity, but with tragedy and a father's love. In September 1935, Hurricane Donna had swept across South Florida, stranding hundreds of families in the vast Everglades. Traditional rescue boats couldn't navigate the shallow marshes, while trucks and ambulances were useless in the flooded terrain. Rescue teams watched helplessly as survivors clung to tree branches and rooftops unreachable by any conventional means. John Roebling, heir to the wire rope fortune that built the Brooklyn Bridge, witnessed the disaster from his estate near Clearwater. His son, Donald, a gifted engineer in his own right, had been experimenting with unusual vehicles in the family's private workshops. The hurricane's aftermath sparked an idea that would change the nature of warfare itself. Donald Roebling had always been fascinated by vehicles that defied conventional limitations. His workshop in Lakeland was filled with half-completed prototypes, abandoned experiments, and mechanical curiosities that served no obvious purpose. Unlike his contemporaries who focused on making cars faster or planes more efficient, Roebling was obsessed with crossing boundaries that others accepted as permanent. The concept seemed simple enough in theory. Create a vehicle that could transition seamlessly between water and land, navigating the treacherous terrain that characterized much of Florida's interior. But the engineering challenges were immense. How do you make something watertight enough to float, yet sturdy enough to carry heavy loads over rough ground? How do you design propulsion that works equally well on land and water? How do you create tracks that can grip both muddy banks and submerged coral? Roebling's first attempts were disasters. Early prototypes leaked immediately upon entering water, their engines flooding and electronic systems failing. Track designs that worked perfectly on land became waterlogged and useless in even shallow water. Weight distribution calculations that looked elegant on paper proved catastrophically wrong in practice, causing vehicles to tip over or become hopelessly stuck. But Roebling possessed two crucial qualities that would prove decisive: unlimited financial resources and obsessive persistence. While government engineers worked within budget constraints and military timelines, he could afford to fail repeatedly, learning from each disaster and incorporating those lessons into the next iteration. The breakthrough came in early 1940 when Roebling discovered that the secret lay not in making a perfect boat or a perfect tank, but in creating something entirely new. His successful design featured a hollow aluminum hull that provided buoyancy, while specially designed rubber tracks could grip both underwater surfaces and dry land. The engine was positioned high enough to avoid flooding, while the transmission system could adjust power distribution between forward propulsion and track rotation. The vehicle that emerged from his workshop looked unlike anything the military had ever seen. Officially designated the Alligator for its amphibious nature, it measured 32 feet in length and could carry 36 men or 4 tons of cargo. In water, twin propellers provided propulsion, while the tracks served as rudimentary steering fins. On land, the tracks took over completely, while the hull's boat-like shape actually helped it navigate obstacles and rough terrain. Testing revealed capabilities that amazed even Roebling. The Alligator could cross water at 7 knots, climb onto beaches with slopes up to 30 degrees, and then continue inland at 15 miles per hour. It could navigate swamps, marshes, coral reefs, rocky shores, and sandy beaches with equal ease. Most remarkably, it could make these transitions without stopping, creating tactical possibilities that no military doctrine had ever considered. Life magazine featured the vehicle in a 1940 article titled "Mechanical Crocodile Conquers Land and Sea," complete with photographs of the ungainly machine churning through Florida swampland. The article described it as a curiosity, a rich man's toy designed for rescue operations. Military planners read it with only passing interest, filing it away as an interesting but impractical innovation. That dismissive attitude changed dramatically on December 7, 1941. When Japanese aircraft struck Pearl Harbor, American military leaders suddenly found themselves facing a strategic nightmare that conventional wisdom had declared impossible. Japan's rapid conquest of the Philippines, Dutch East Indies, and island chains across the Central Pacific had created a defensive perimeter protected by some of the most challenging amphibious terrain on Earth. The Japanese had studied American military doctrine extensively. They knew that successful amphibious assault required deep-water harbors where large ships could deliver troops and supplies. Their defensive strategy was elegantly simple: fortify every major port and airfield while positioning mobile reserves to counterattack any landing force during its most vulnerable moments. But Japan's defensive genius lay in their exploitation of natural barriers. The coral atolls, reef systems, and shallow lagoons that characterize the Central Pacific created hundreds of miles of impassable water. Traditional landing craft required deep channels and clear beaches to operate effectively. Japanese planners were confident that American forces would be forced to assault heavily defended conventional beaches, where pre-positioned artillery and machine gun nests could devastate attacking formations. Admiral Chester Nimitz, newly appointed commander of the Pacific Fleet, faced an impossible puzzle. Every strategic objective lay behind walls of coral that conventional naval forces couldn't cross. Intelligence reports described elaborate defensive preparations on every major island, with particular attention paid to beach defenses that would turn any assault into a slaughter. The problem extended far beyond simple geography. American amphibious doctrine in 1942 was primitive compared to what it would become. Landing craft were basic wooden boats designed for short trips between ship and shore in calm water. Once troops reached the beach, they had to establish supply lines back to deeper water where larger ships could operate safely. This created predictable patterns that Japanese defenders could easily disrupt. Lieutenant Colonel Victor Krulak of the Marine Corps had been studying these challenges when Life magazine's article about Roebling's amphibious vehicle caught his attention. While other officers saw an interesting gadget, Krulak recognized revolutionary potential. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a vehicle that could cross coral reefs, navigate shallow lagoons, and deposit troops directly onto defended beaches would render Japan's entire defensive strategy obsolete. Krulak's report to Marine Corps headquarters was prophetic in its vision, but understated in its language. He simply noted that recent technological developments might offer solutions to Pacific amphibious challenges and recommended immediate evaluation. What he privately understood was that Roebling's machine could transform the entire character of Pacific warfare. The first official military test took place at Quantico in March 1942. Roebling personally demonstrated his vehicle for a group of skeptical officers who expected another failed experiment. Instead, they witnessed something that challenged every assumption about amphibious warfare. The Alligator entered Chesapeake Bay, navigated underwater obstacles that would have destroyed conventional landing craft, and emerged onto a rocky shore that no boat could have approached. More importantly, it did all of this while carrying a full load of Marines who disembarked ready to fight immediately. No waiting for follow-up waves, no establishing beachheads, no vulnerability during the critical transition from ship to shore. The vehicle simply arrived, opened its rear doors, and deployed combat-ready troops wherever they were needed most. Marine Corps Commandant Thomas Holcomb watched the demonstration with growing excitement. Here was a solution to problems that had seemed insurmountable just weeks earlier. But Holcomb also understood that military bureaucracy could kill promising innovations through endless testing and modification. He made a decision that would prove crucial to the Pacific War's outcome: immediate full-scale production without waiting for further refinement. The Navy's Bureau of Ships initially resisted the project, arguing that proper development would require years of testing and improvement. They proposed a cautious approach involving small-scale trials and gradual implementation. Holcomb overruled them, demanding immediate production of 200 vehicles for Pacific deployment by early 1943. Donald Roebling found himself transformed overnight from curious inventor to essential war contractor. His small workshop in Lakeland became the center of a massive industrial effort involving dozens of subcontractors and thousands of workers. The vehicle that had been his personal project was now designated the LVT, Landing Vehicle Tract, and given top priority classification. Production challenges were immense. The original Alligator had been essentially handmade, with custom fittings and individually adjusted components. Mass production required complete redesign of manufacturing processes while maintaining the vehicle's unique capabilities. Roebling worked 18-hour days supervising every aspect of production while continuing to refine the basic design. The first major modification involved armor protection. Roebling's original vehicle had been built for rescue operations, not combat. Military versions needed protection against small arms fire and shell fragments while maintaining their amphibious capabilities. Adding armor without destroying buoyancy required delicate calculations and extensive testing. Armament presented another challenge. The vehicle needed weapon systems for both assault and defense, but traditional tank turrets were too heavy and would compromise stability in water. The solution involved mounting machine guns and small cannons in positions that provided adequate firepower without disrupting the vehicle's center of gravity. Engine modifications were equally crucial. Marine environments demanded different performance characteristics than the Florida swamps where the original had been tested. Saltwater corrosion, sand infiltration, and extended operation under combat conditions required major engineering changes. New cooling systems, filtration methods, and maintenance procedures had to be developed specifically for Pacific conditions. By late 1942, the first production LVTs were rolling off assembly lines in Pennsylvania and Louisiana. Each vehicle represented months of intensive development work, incorporating lessons learned from previous models while anticipating challenges that hadn't yet been encountered. The machines that emerged bore only superficial resemblance to Roebling's original Everglades rescue vehicle. Training programs began immediately at newly constructed facilities in California and North Carolina. Marine crews had to master vehicle operation, maintenance, and tactical employment while learning completely new amphibious assault techniques. Traditional Marine doctrine emphasized rapid movement from ship to shore, followed by conventional ground combat. LVT operations required thinking in 3 dimensions, with seamless transitions between naval and land warfare. The psychological impact on training units was significant. Marines who had trained for beach assaults expecting heavy casualties suddenly found themselves practicing operations that bypassed traditional defensive positions entirely. Instead of charging across open beaches under enemy fire, they could approach from unexpected directions, cross barriers that defenders considered impassable, and establish positions deep inland before resistance could organize. But the true test would come not in training exercises, but in actual combat against Japanese forces that had spent months preparing for conventional American tactics. Intelligence suggested that Japanese commanders were confident in their defensive preparations, expecting American forces to follow predictable patterns that could be easily countered. What they didn't expect was a vehicle that could ignore the rules of amphibious warfare entirely. The coral reefs that formed Japan's primary defensive barrier were about to become highways for an invasion force unlike anything the world had ever seen. The stage was set for a revolution in military tactics that would catch one of history's most formidable defensive forces completely unprepared. The transformation from Donald Roebling's Hurricane rescue vehicle to America's secret weapon had taken less than 2 years. Soon, those ungainly machines would be crawling across Pacific coral reefs under enemy fire, carrying Marines to objectives that Japanese planners had declared unreachable. The age of amphibious warfare was about to change forever. November 20th, 1943, Betio Island, Tarawa Atoll. Major General Julian Smith peered through his binoculars at what appeared to be an impenetrable fortress rising from the Pacific. 4,000 Japanese Marines under Rear Admiral Keiji Shibazaki had spent 18 months transforming this tiny coral island into what they boasted was an unsinkable aircraft carrier. Concrete bunkers studded the shoreline like barnacles on a ship's hull. Artillery pieces commanded every approach. Machine gun nests covered overlapping fields of fire across beaches that the Japanese were certain no enemy could reach alive. What Admiral Shibazaki didn't know was that 75 tracked vehicles were approaching his supposedly impregnable coral barrier from directions he had never considered possible. The first wave of LVT alligators had been circling 30 miles offshore since dawn, their crews studying tide charts and coral formations that conventional military wisdom declared impassable obstacles. These weren't the deep-water approaches the Japanese defensive doctrine had anticipated. They were routes that no landing craft in history had ever attempted. Captain Robert Schrud of Time magazine had embedded with the 2nd Marine Division specifically to document what military analysts predicted would be the bloodiest amphibious assault of the Pacific War. Intelligence estimates suggested casualties approaching 50% during the initial landing phase alone. The coral reef surrounding Betio extended over 800 yards from the beach, creating a killing field where traditional landing craft would ground helplessly while Japanese artillery found their range. But as Schrud watched from the command ship, something unprecedented began unfolding. The first LVTs approached the reef not with the cautious probing of conventional naval forces, but with the mechanical confidence of vehicles that treated water barriers as minor inconveniences. Track Commander Lieutenant Frank Morrison had spent weeks studying underwater topography maps, identifying routes across the coral that his vehicle could navigate even at low tide. Morrison's LVT, designated Gator 7, carried 28 Marines from Charlie Company, 3rd Battalion. These weren't elite reconnaissance troops or specialized assault forces. They were standard infantry who had trained for traditional beach assaults involving rushes across open sand under heavy fire. Now they found themselves passengers in a machine that was rewriting the rules of amphibious warfare in real time. The transition from deep water to coral reef occurred without drama. Morrison simply adjusted his throttle settings and continued forward as his tracks found purchase on underwater coral formations. Behind him, 17 more LVTs followed in loose formation, each vehicle navigating independently while maintaining visual contact with adjacent units. What should have been an impossible approach became a mechanical parade across terrain that Japanese defenders had dismissed as impassable. From his command bunker, Admiral Shibazaki watched through periscope observations as dark shapes moved across water where no ships should have been able to operate. His first reaction was confusion rather than alarm. Intelligence reports had provided detailed information about American landing craft capabilities. These vehicles were clearly different, but their significance wasn't immediately apparent. Japanese defensive planning had focused entirely on beach approaches where landing craft would deposit troops at the water's edge. Artillery coordinates had been precisely calculated for these predictable landing zones. Machine gun positions provided interlocking fire across conventional approach routes. Minefields and obstacles were positioned to channel attacking forces into predetermined killing zones. But the LVTs weren't following any of these expected patterns. Instead of grounding on the reef and discharging troops into chest-deep water for a desperate wade to shore, they simply continued moving. Coral formations that would have gutted conventional landing craft served merely as minor navigation hazards for vehicles designed to operate in Florida swampland. Lieutenant Morrison's vehicle reached the beach 17 minutes after crossing the outer reef edge. During that entire approach, Japanese defenders had been unable to bring effective fire to bear because their weapons were positioned for different target areas. By the time lookouts realized what was happening, Morrison's Marines were already deploying on dry land behind the primary defensive line. The tactical implications were revolutionary, but not immediately obvious to either side. Japanese resistance was fierce once they understood what was occurring, but their defensive positions had been designed for threats approaching from predictable directions. Machine gun nests faced seaward toward expected landing zones. Artillery pieces were positioned to interdict forces advancing across open beaches. None of these preparations were optimally positioned for enemies emerging from unexpected directions. Marine Sergeant William Hayes, riding in Morrison's vehicle, later described the experience as surreal. His unit had spent months training for what everyone expected to be a brutal beach assault involving high casualties and uncertain outcomes. Instead, they found themselves stepping onto solid ground behind Japanese positions that were still oriented toward threats that hadn't yet materialized. But the real revolution wasn't tactical surprise, though that proved significant. The fundamental change was logistical. Traditional amphibious assaults required establishing and maintaining supply lines across contested beach areas where enemy fire could disrupt operations for days or weeks. LVTs could carry supplies directly from ship to inland positions, bypassing vulnerable beach zones entirely. Gator 12, commanded by Corporal James Patterson, demonstrated this capability during Tarawa's second day. Instead of carrying assault troops, Patterson's vehicle was loaded with ammunition, medical supplies, and communications equipment needed by Marines advancing into the island's interior. He approached the reef before dawn, navigated the coral barrier during darkness, and delivered his cargo to forward positions without exposing supply lines to enemy interdiction. Japanese defenders adapted quickly once they understood what they were facing. Admiral Shibazaki repositioned artillery pieces to cover previously ignored approach routes. Machine gun positions were relocated to provide better coverage of inland areas where LVTs were delivering troops. Defensive doctrine was hastily revised to account for enemies who could appear from any direction at any time. But adaptation takes time, and time was the one resource Japanese garrisons couldn't manufacture. The LVTs had achieved something unprecedented in amphibious warfare. They had eliminated the critical vulnerability period when attacking forces transitioned from naval to ground operations. Traditional beach assaults created predictable windows when defenders could concentrate fire against exposed troops. The tracked vehicles eliminated those windows entirely. Technical Officer Commander Harold Stevens had been assigned to document LVT performance for future tactical development. His reports to Naval Headquarters described capabilities that seemed to violate established principles of amphibious warfare. Vehicles that could cross barriers previously considered absolute. Supply operations that bypassed contested zones entirely. Assault forces that could establish positions before defenders could respond effectively. But Stevens also noted significant limitations that would influence future Pacific operations. The LVTs were mechanically complex, requiring extensive maintenance in harsh marine environment. Their armor protection was adequate against small arms, but vulnerable to direct artillery hits. Most critically, their load capacity was limited compared to conventional landing craft, restricting the size and type of equipment they could transport. These limitations became apparent during Tarawa's raider phases when Marines required heavy equipment for reducing fortified positions. LVTs could deliver infantry and light supplies effectively, but tanks, artillery pieces, and engineering equipment still required conventional landing craft operating from deeper water. The revolution in amphibious tactics was significant but not complete. Japanese military analysis of Tarawa focused heavily on the new American vehicles and their implications for future defensive planning. Colonel Tadashi Suzuki's after-action report to Imperial General Headquarters described the LVTs as a fundamental challenge to established defensive doctrine. Machine gun nests faced seaward toward expected landing zones. Artillery pieces were positioned to interdict forces advancing across open beaches. None of these preparations were optimally positioned for enemies emerging from unexpected directions. Marine Sergeant William Hayes, riding in Morrison's vehicle, later described the experience as surreal. His unit had spent months training for what everyone expected to be a brutal beach assault involving high casualties and uncertain outcomes. Instead, they found themselves stepping onto solid ground behind Japanese positions that were still oriented toward threats that hadn't yet materialized. But the real revolution wasn't tactical surprise, though that proved significant. The fundamental change was logistical.
Traditional amphibious assaults required establishing and maintaining supply lines across contested beach areas where enemy fire could disrupt operations for days or weeks. LVTs could carry supplies directly from ship to inland positions, bypassing vulnerable beach zones entirely. Gator 12, commanded by Corporal James Patterson, demonstrated this capability during Tarawa's second day. Instead of carrying assault troops, Patterson's vehicle was loaded with ammunition, medical supplies, and communications equipment needed by Marines advancing into the island's interior. He approached the reef before dawn, navigated the coral barrier during darkness, and delivered his cargo to forward positions without exposing supply lines to enemy interdiction. Japanese defenders adapted quickly once they understood what they were facing. Admiral Shibazaki repositioned artillery pieces to cover previously ignored approach routes. Machine gun positions were relocated to provide better coverage of inland areas where LVTs were delivering troops. Defensive doctrine was hastily revised to account for enemies who could appear from any direction at any time. But adaptation takes time, and time was the one resource Japanese garrisons couldn't manufacture. The LVTs had achieved something unprecedented in amphibious warfare. They had eliminated the critical vulnerability period when attacking forces transitioned from naval to ground operations. Traditional beach assaults created predictable windows when defenders could concentrate fire against exposed troops. The tracked vehicles eliminated those windows entirely. Technical Officer Commander Harold Stevens had been assigned to document LVT performance for future tactical development. His reports to Naval Headquarters described capabilities that seemed to violate established principles of amphibious warfare. Vehicles that could cross barriers previously considered absolute. Supply operations that bypassed contested zones entirely. Assault forces that could establish positions before defenders could respond effectively. But Stevens also noted significant limitations that would influence future Pacific operations. The LVTs were mechanically complex, requiring extensive maintenance in harsh marine environment. Their armor protection was adequate against small arms, but vulnerable to direct artillery hits. Most critically, their load capacity was limited compared to conventional landing craft, restricting the size and type of equipment they could transport. These limitations became apparent during Tarawa's later.
Traditional coral reef barriers were no longer reliable obstacles. Beach defense positions needed complete reconsideration. Suzuki recommended immediate development of countermeasures specifically designed for amphibious vehicles, underwater obstacles that could damage tracks, artillery techniques for engaging moving targets in shallow water, revised defensive positions that provided better coverage of previously ignored approach routes. His report initiated a comprehensive review of Pacific defensive strategy. But Japanese adaptation efforts were constrained by resource limitations and strategic realities. The coral atolls that needed defending numbered in the hundreds, while Japanese construction capacity was already stretched beyond limits. Fundamental defensive revisions would require time, materials, and expertise that simply weren't available. American tactical doctrine evolved much more rapidly. The success at Tarawa demonstrated that LVTs could revolutionize amphibious operations, but also revealed areas needing improvement. Vehicle reliability needed enhancement. Armor protection required upgrading. Load capacity demanded expansion. Most importantly, coordination between LVTs and conventional forces needed refinement. Major General Holland Smith, commanding the 5th Amphibious Corps, immediately ordered comprehensive tactical reviews of all planned Pacific operations. Traditional assault plans based on conventional landing craft were scrapped in favor of new approaches that maximized LVT capabilities while minimizing their limitations. The entire Pacific campaign timeline was accelerated based on the tactical advantages these vehicles provided. Production priorities shifted dramatically as military planners realized the strategic implications of amphibious vehicles that could ignore traditional barriers. Donald Roebling found his manufacturing facilities designated as critical war production, with unlimited resources and highest priority materials allocation. The vehicle that had started as a hurricane rescue project was now central to American Pacific strategy. Design modifications accelerated based on combat experience. Improved armor packages provided better protection without compromising buoyancy.
More powerful engines enhanced performance in challenging conditions. Better weapon systems gave vehicles independent combat capability beyond simple transportation. Each modification was tested, refined, and implemented with unprecedented speed. Training programs expanded to accommodate demand for qualified crews. The peculiar skills required for amphibious vehicle operation couldn't be learned through traditional military instruction. Operators needed to understand both nautical and automotive principles while mastering tactical employment in constantly changing conditions. These skills took months to develop properly. Lieutenant Morrison, whose successful reef crossing at Tarawa had demonstrated LVT potential, was reassigned to training duty in California. His experiences became the foundation for new tactical doctrines that would be employed throughout the Central Pacific Campaign. The lessons learned crossing Tarawa's reef were systematically incorporated into standard operating procedures for future operations. Meanwhile, Japanese forces throughout the Pacific began receiving reports about American amphibious vehicles and their tactical implications. Local commanders started modifying defensive preparations based on limited information about capabilities they had never encountered directly. These modifications were often inappropriate for local conditions, but they reflected growing understanding that traditional defensive assumptions were no longer valid. The psychological impact on Japanese defenders was significant. Coral reefs had provided psychological as well as physical security. Knowing that attacking forces would be channeled into predictable approaches gave defenders confidence in their preparations. The realization that Americans could approach from any direction at any time created uncertainty that undermined defensive morale. But the most profound impact was strategic. The Central Pacific Campaign that had seemed impossibly costly using conventional amphibious techniques suddenly became feasible with LVT's spearheading assaults. Islands that Japanese planners considered impregnable due to coral barriers were now vulnerable to attack from unexpected directions. The entire Pacific War's trajectory was shifting based on vehicles that could crawl across underwater obstacles. Admiral Chester Nimitz, reviewing intelligence reports about Japanese defensive modifications throughout the Pacific, realized that tactical innovation was creating strategic opportunities. The Coral Fortress barrier that had seemed to protect Japan's Pacific perimeter was becoming a highway for American forces equipped with vehicles that treated underwater obstacles as minor navigation challenges. At Pearl Harbor, planning staffs began revising operation timelines based on LVT capabilities. Objectives that had been scheduled for late 1944 were moved to early schedules. Force requirements were reduced as tactical advantages eliminated the need for massive assault formations. The Pacific War was accelerating beyond anyone's initial projections. The implications extended beyond immediate tactical applications. If amphibious vehicles could cross coral reefs under fire, what other barriers might they overcome? Japanese defensive planning had relied on natural obstacles to channel and contain American advances. Those obstacles were proving less absolute than anyone had imagined. As 1943 ended, American forces were preparing for the next phase of the Central Pacific Offensive with confidence that would have seemed impossible just months earlier. The Marshall Islands beckoned. Their coral atolls no longer barriers, but merely navigation challenges for vehicles that had revolutionized amphibious warfare. Japanese defenders waited behind fortifications designed for enemies who would never arrive as expected. The age of impregnable coral fortresses was ending. In its place came an era of three-dimensional warfare where land, sea, and underwater terrain merged into seamless battlefields. The humble rescue vehicle born in Florida swampland had evolved into the key that would unlock Japan's Pacific fortress chain. The real test was yet to come, but the revolution had already begun. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.